Hey everybody, this is Christian, and in this video I want to show you how I'm managing HTTPS for my applications on my new Raspberry Pi Kubernetes cluster. This is kind of a follow-up to my previous videos where we have installed K3s and KubeVip on 3 Raspberry Pis, and also somewhat to my last Traefik tutorial on Docker. Today all these different puzzle pieces are coming together, so we will cover installing Traefik in Kubernetes as well as how you can use it to expose any of your applications. And to throw one more thing into the mix, we will also install Cert-Manager, so that allows you to easily protect these applications with trusted TLS certificates from Letsencrypt. This is my ultimate solution for providing a secure connection to any services deployed on Kubernetes. So no matter if you want to use this on K3s in your local network or you want to use it on cloud services like AKS or EKS, this is super amazing. Of course, I know this video requires some previous knowledge about all these technologies I just mentioned, so K3s, KubeVip and Traefik. So if you haven't watched my previous videos yet, I'm going to put you the links to them in the description box down below so you can easily follow along. But before we install and deploy Traefik on Kubernetes, I also want to quickly talk about remote access, because when I need to log in to any of my virtual servers or applications on my container orchestrators from anywhere, I use TwinGate, the sponsor of today's video. TwinGate is a zero-trust network access platform that is honestly so much better and more secure than using traditional VPNs, because it always verifies each access request. If the user isn't authorized, if the device isn't verified, or the context is suspicious, TwinGate doesn't let the network request even leave the device. If you're following this channel, you probably know that I've made some tutorials about TwinGate in the past. One that I want to highlight in this context here is the Zero Trust Networking for DevOps video. So there I have explained how to set up and configure TwinGate using Terraform and integrating it into Kubernetes. So that might be interesting to watch, but of course you can also use it with any of your applications or devices, no matter if you need to securely log into administrative interfaces or to an SSH server, even through NAT firewalls. TwinGate is absolutely the right tool for this. And the best, you can use TwinGate entirely for free up to 5 users and 10 different remote networks. So definitely check it out, start making your network more secure and safe. Of course, I will leave you a link to their website in the description box down below. Okay, so let's get started with Traefik on Kubernetes. First, I want to quickly recap what we've done in the previous videos and how Traefik and Cert-Manager fit into the scope of this project. For this demonstration, I've installed a fresh new testing Kubernetes cluster on 3 virtual Ubuntu servers, but I've just followed the same installation procedure as on my Raspberry Pi video. That is, by the way, also the same setup I'm using on my production machines. And there I'm using KubeVip, which is responsible for load balancing incoming network requests to any of the active nodes in the cluster. So this makes sure we can always reach the cluster from our local network, even if we need to restart a particular node. Just like I've shown you in the previous videos, I've also deployed the KubeVip cloud controller and configured a range of IP addresses in my local network, which are automatically assigned to any new service objects from the type load balancer. So this is nice, because then we can just expose any applications on this Kubernetes cluster to the entire local network. In this video, I did a quick test with the Nginx web server, for example. As you can see, it automatically got a new IP address that we can simply enter in the address bar of our browser to get access to this application in the cluster. So far, so good. But of course, if we want to make sure that our network connection is always encrypted, for example, we always want to use HTTPS, and we also need trusted TLS certificates to get rid of this certificate warning in the browser, we have to expand this setup a little. Instead of exposing applications directly using the service objects, we will install the free and open source reverse proxy Traefik. And for any application that we wish to make accessible on our cluster, we will again use a wildcard record on my local DNS server that resolves to the IP address of Traefik. Again, I've explained this in my last Traefik tutorial. In this video, we have basically done the same thing, except that we've just done it on Docker. And today we're doing it on Kubernetes. But let's go through all of these necessary steps one by one together, so I think that makes it a bit simpler to follow. Alright, so to install Traefik on this Kubernetes cluster, we simply open the official documentation of Traefik and follow the installation procedure. Now here you have different ways of installing this application, the official Docker image or binary distributions and so on. But of course, in Kubernetes, I'm always installing anything using the Helm chart if that's possible, because it makes it so much easier to deploy this. If you have installed the Helm tool, you just need to add the Traefik repository to your Helm repos. So on my workstation, I've already done this, so let's do it in update. And then in the installation instructions, you can use the Helm install command to deploy Traefik on your Kubernetes cluster. Now, before I want to do this, I want to customize a couple of settings that we need. Here in the custom values, you can find a default values file that contains all the different settings of this chart. So here you can configure and customize any of these settings or additional objects, annotations, whatever you want to customize to your application. So by default, the configuration is quite nice, but there are two things that I actually want to change. Because as you might remember from my last Traefik tutorial, I always like to redirect any incoming connections to the insecure HTTPS protocol to the secured web protocol on port 443. And in Docker, we had to configure this in the static configuration file of Traefik. Now, using the Helm chart, we can simply find it here in the default section under ports. So here you can customize any of the entry points. And here in the web section, there is an example for redirecting it by default to HTTPS. Now, to do this, I want to open my project directory and create a new Helm values file. I'm just going to call it Traefik values.yaml. And here I want to add the ports section and set the web entry point redirect to. And note, Copilot is still suggesting me the old way, how it was done in Traefik version 2, but in version 3 it actually did change the Helm chart a bit. So here we need to define it in ports, web secure. And that's it. So add any other customizations to this Helm values file if you want, and then simply install a new instance of Traefik. I want to add this to the namespace Traefik and automatically create this namespace. And I want to use the values file Traefik-values that we've just created. So this will install and deploy the Traefik reverse proxy to Kubernetes. So let's check if everything was successfully created. So we will just query all the ports in the Traefik namespace. And now what is interesting, Traefik will automatically create a service object from type load balancer. So let's query the service objects in that namespace to see if it got an external IP address from my local network. And yes, the kubeweb load balancer automatically assigned the first available IP address from the defined range, which is 10.20.22.21, to the Traefik load balancer service object. So anything that we send to this IP address will be picked up by Traefik. Okay guys, so that's it to get Traefik successfully running on Kubernetes. I think that is pretty simple. Now we can start exposing our applications. And I just want to show you some example here. Of course, I've already prepared a deployment of an Nginx web server that is currently running with 3 ports. Those ports are running across the entire cluster, one for each node that I have deployed. And I've also created a service object with the type ClusterIP. So that will automatically load balance any incoming requests to the internal cluster IP to all of the ports distributed on the nodes. Now, if you remember my Traefik Docker video, we had to do 2 things. Firstly, we needed to create an FQDN, a fully qualified domain name, for the application on my local DNS server, so that any requests to our applications are forwarded to the IP address of Traefik. In this case here, we need to add the IP address of the Traefik service object that it got from kubeweb, and use a wildcard in the DNS record, meaning anything in front of this hostname will be resolved to the Traefik IP as well. And then we just had to configure a router for this application to tell Traefik, hey, please forward any request for this FQDN to the internal service of the application. And we did this by adding labels in the Docker Compose file of the application. However, this was using the Docker provider, of course. Now we need to configure this using a Kubernetes provider. As you can see in this table of the Traefik provider documentation, if we are using Traefik in Kubernetes, we actually have 3 different providers where Traefik can get its configuration from. The Kubernetes Ingress route, also named Kubernetes CRD, which uses custom resource definitions in Kubernetes. Then we have the normal Kubernetes ingress, which is a standard resource type that doesn't only work for Traefik, which is sometimes nice for compatibility, because if you might want to use a different ingress controller than Traefik, like Nginx or something else, the ingress definitions are always configured in the same way. So they follow a standard format that you can use. And then there's also the Kubernetes Gateway API. However, we don't want to mess around with this one to not make it unnecessarily complex. Now, to enable or disable the one or another provider in Traefik, you can easily modify the values in the Helm file if you like. You just need to search for the provider section. And as you can see, both providers, the Kubernetes CRD and the Kubernetes Ingress provider, are automatically enabled by default. So it is basically up to you what you're using. You can create ingress or ingress route objects in your cluster. Traefik will dynamically load all these settings into its configuration. Now, what I want to do is I want to change a couple of things here. For example, I want to give this a name, and of course, you have to create these objects in the namespace where the workloads are deployed. And you also have to use an annotation here if you want to customize the web entry points and make this available on the web secure entry point, for example. Then you have to add this annotation here. Now, this example is a bit, I don't need any of this, so I'm going to remove this here. Now, here in the host section, I want to add an FQDN for this application. For example, Nginx, whatever I want. And use the kubetest1.home.crave.de server name. And then I just want to expose anything on the root path. We'll use this as a prefix. And then forward this to the backend service with the name Nginx. So you need to use the same service name. And yeah, that should be all. Now we can just apply this manifest to the cluster. And yeah, let's also query this to see if it was created successfully. Open a new browser window and just type the name that we have defined here, and see if Traefik forwards it to the actual application. This is an insecure connection, so if we continue, it will automatically redirect us to the HTTPS website. And yeah, let's just proceed, and then you can see we get the website of our pod that we have exposed, like the Nginx web server. Now, I also want to just demonstrate how that's working using the ingress route object, so I'm just going to delete this manifest again. So here we don't have a nice template, unfortunately. Yeah, sometimes the Traefik documentation is a bit off here. But anyways, what is quite interesting for the ingress route object, they work actually the same way like ingress objects, but they give you a couple of more options that are fine-tuned for the Traefik reverse proxy. So that means the ingress route is only Traefik specific and it won't be picked up by any other ingress controller that you might install in the cluster. And honestly, I like the ingress route object a bit more than the default ingress object because it's a bit simpler to configure. Here in the specifications, you just choose your entry points and then you can add routes for a specific matching here. And this allows you to add those Traefik-specific configurations when you go back to the documentation and go to routing and load balancing routers. So here you can add all these different options here. You can add matchings based on headers, on header regular expressions, on host regular expressions, on paths, path prefix, specific queries or client IPs, and any of those rules you can define in the ingress route object. And that gives you many more options to customize any of the matching requests. Now, for this very basic example, it's not really making a big difference, but if you're configuring any of those specific settings here, the ingress route object will give you much more options to do that. And now let's also apply this resource to see how that's working. And then we should be able to make the same request to the web server again. Now, I also want to show you one more thing, because in my Traefik Docker video, I've showed you the dashboard of Traefik, and you might wonder if you can enable this in Kubernetes as well. And yeah, you can do that. In the Helm chart, there is a setting for ingress route that will automatically create an ingress route for the Traefik dashboard. Note, don't do this in production, so don't expose the Traefik API or dashboard insecurely. By the way, in some future videos, I will show you a better way how to protect this with user authentication and so on, but yeah, that's a topic for a different video. So let's customize those settings here to expose the dashboard. I will enable it, but by default, the matching entry point is set to the Traefik entry point, and that is not exposed by default. So I will change this and set it to entry points web and web secure. And I will add a match rule to this, where I can customize a name. For example, Traefik or Traefik dashboard. I think Traefik dashboard might be better. on this particular hostname. So when I update my Helm deployment, so you can easily use just the same command, but instead of install, just call it upgrade. And then it's upgrading the configuration with the changed configs from the new values. And then if we query the IngressRoute objects, and let's query this for all namespaces. For example, you can see there is our IngressRoute for the Nginx web server that I've just created. And there's another one that is managed by Traefik for the Traefik dashboard. So when I open this location, Traefik dashboard, so there you can see I've got redirected to the Traefik dashboard. Oh my god, my eyes are bleeding, so let me switch that to the dark mode. All right, fine, that's much better. And here we can, inspect all the details of the HTTP routers, the rules, and so on. Here you can see our Nginx kubetest 1 web secure ingress route. You can see it has TLS enabled. But of course, if we go back to this, you can see it is not secure because it is using the default certificate of Traefik. Of course, this is something that we have to configure as well. Alright, so I think until this point, if you have watched my Traefik tutorial on Docker, it should be all pretty familiar how to add additional configuration to the Ingress or IngressRoute objects. But now comes the part that is a bit difficult in Traefik to do, and that is when you want to issue trusted TLS certificates from Letsencrypt. So if you want to get rid of this certificate warning in the browser. And the problem is that Traefik on Kubernetes likes to store its TLS certificate in a persistent storage volume, which is not ideal, to be honest, since these persistent volumes have to be created with the RWX access mode. Otherwise, not all the pods on every node have access to the exact same volume. So if you want to scale traffic across the entire cluster, you might get some problems. And this can become quite complicated if you're not using a storage backend in Kubernetes that supports the access mode. Long story short, just don't use Traefik in Kubernetes to manage TLS certificates. Instead, I want to show you a better way to do this, and this is called Cert-Manager. Cert-Manager is a free and open source tool for simple and easy certificate management in Kubernetes, which allows you to easily issue trusted TLS certificates using the ACME protocol. You can also do a DNS challenge via Cloudflare and so on. But the interesting advantage of Cert-Manager instead of using Traefik is that Cert-Manager doesn't use persistent storage volumes. Instead, it uses Kubernetes objects, which is great because these Kubernetes objects are automatically available to any node, any pod, any admin in the cluster, and they are stored in the etcd database in Kubernetes as simple secret objects. So you don't have to mess around with persistent volumes. You can even create these certificate objects using simple Kubernetes manifests and better integrate it into any Ingress or IngressRoute configs. It is so much easier, so let's get into it. Alright, now let's deploy Cert-Manager on this Kubernetes cluster as well. And as you can see, the documentation is much better because it follows a very strict path that you just need to go through. First, the installation, and here you can get all the different ways how to deploy this. Of course, we are using Helm again, so I think that is the best way. You can just copy and paste this command. It automatically adds a repository and does an update. And then you can install Cert-Manager using these commands here. So this is a pretty good command for a simple and easy deployment. But of course, I want to customize a couple of things here. So I'm going to add a new Helm values file for Cert-Manager. And here, I think they don't have a link to their default Helm values. Here you can see a full list of these values. So let me open this and go to default values. So here you can see what you can customize. One thing that is actually pretty important is the CRDs, because the installation of the custom role definitions that Cert-Manager uses are usually not enabled by default here, but you can also define it in the Helm values file if you need. So if you just add CRDs enabled true, and you can also customize a specific namespace for this. By default, it is always Cert-Manager, I believe. So that should be fine. And now comes something that is pretty important if you're running a local DNS server like I'm doing in my home lab. But of course, you need to use external DNS servers to resolve the names and not the internal ones. So therefore, in the extra arguments, you can add some additional command line instructions. And here you need to use this here, the DNS1 recursive name servers only setting. And the next one is recursive name servers, and then you set them to, I think you can just use the default name servers of Cloudflare, those two IP addresses, and that should be all Now you can simply deploy Cert-Manager using Helm. You should deploy this in the namespace Cert-Manager. This is actually pretty important because it looks for specific objects in that namespace. I also want to create this by default and use the Cert-Manager values file that we have added here. And don't worry if this takes a couple of seconds. So it actually has some sort of health check. So it waits for everything to be up and running correctly. So now let's query if everything is up and running. And now that we have deployed Cert-Manager, we need to configure a couple of things here. So let's go to the second section. First of all, we need to configure something that is called issuers, or a cluster issuer. And these objects basically represent a CA, a certificate authority, which is responsible for creating and signing the TLS certificates. With a small difference, the issuer objects can only be used in the namespace they are created in, while the cluster issuer resources can be used throughout the entire cluster, so they aren't limited to a particular namespace. Now, in the documentation, you can see a full list of all the Cert-Manager issuer integrations. The most prominent one is the ACME issuer, which uses the Automatic Certificate Management Environment Protocol, and that is mostly used to issue TLS certificates from trusted CAs like Letsencrypt, for example, which are always trusted by default by any client device in the world. Now for this demonstration, I'm creating a cluster issuer object because I want to use this to automatically generate certificates in all namespaces of the cluster. So you can use this as a general CA that issues and creates all your certificates. And we're using it together with the Cloudflare service to create and sign the certificate. As I have explained this in my Traefik Docker tutorial, this is in my opinion the most simple and easiest way to issue trusted TLS certificates for a public domain. For additional reference, of course, watch the Traefik video. Now, again, we need to start with a Cloudflare API token. So you have to create a secret object first. And let me just add this Cert-Manager issuer secret, for example. Paste this template in here. And what is pretty important is that you store this in the namespace Cert-Manager. And here you need to add your API token. So let's quickly create a new API token on Cloudflare. So here you just need to go to your profile section. People watching the Docker video will remember this pretty well. So let's just create a new token for my clcreative.de domain. And yeah, I'm probably just giving this a name, temporary Cert-Manager. And let's go to summary, create the token. And this you can simply copy and paste into the API token. One thing I might want to highlight here, so I had some problems with this in the past when I was using a base64 encoded string of the API token. For example, using this method here, and you copy this, this will not work with the string data object. So if you encode it using base64, you need to use data. That issue took me a couple of hours to troubleshoot, so make sure to remember this. Now let's apply this. So here you can see is our API token. And now we need to create a cluster issuer. So let's go back to the documentation. And we will use this template here with just one change. So we will change the kind from issuer to cluster issuer. So then it's valid for the entire cluster. And what we also need to do, I'm going to change the name to Cloudflare cluster issuer, but just use any name that you like. And we also need to add some customizations here. I'm not sure why it is not in this documentation, but if you go to intro, you can see you need to set the email address, and you can also change the server. If you might want to do a test, then you probably should use a staging server and later switch to production. So here I've entered my email address, and I'm using the production server of Letsencrypt so that the certificate is definitely valid. You might also want to add a private key reference here. And then in the solver sections, we are using the DNS challenge using the Cloudflare provider. And here in the API token reference, we need to add the name of our secret value that we have created. Case that name here. I think I just picked the name from the documentation. And the key is API token. So make sure that the API token key matches this here. And then if we got that, we can just apply this as well. Now we can start issuing a certificate for the Ingress route of Nginx. And that's also pretty straightforward. You just need to create another manifest from the type certificate. So here you can find some templates in the documentation. By the way, you can see this is a pretty huge template. Yeah, don't worry, you don't have to use all the different details here. These are all the customizations you can make to this. Of course, I'm using a different template that is a bit shorter. So let's go in here and let's create for the Nginx a new object that I'm just gonna call certificate. And I'm gonna use, yeah, I think I'm just gonna use the first part of this here. I'm just gonna call this Nginx ingress route certificate. And I want to create this in the namespace Nginx, because this is now for the application, this is not for Cert-Manager. The Cert-Manager will use this manifest to issue, generate, and store a certificate, and the certificate itself is then later stored in a secret object. And the name of the secret object that it is stored in, you can define here in this setting. I'm just gonna set this to Nginx certificate secret. I think that is pretty straightforward. And then we need to add an issuer reference. And yeah, GitHub Copilot was smart enough to add our cluster issuer that we've generated in here as well. So I think that looks good. And then we can specify the DNS names. So for which DNS names should this certificate be valid? Let's just add the Nginx kubetest1 DNS name. So the same that matches in the ingress route, so that it's valid for this FQDN. And that's basically all you have to do. If you have configured the cluster issuer correctly, you can just apply this certificate and then the object is generated. So the certificate generation and signing process is fully automatic. In the end, you should get this secret object that contains the actual certificate chain. So let's go back to the ingress route and let's add another section in here that is called TLS. And here we just set the secret name to Nginx certificate secret. So now we can update the ingress route. And if we now reload the page, let's open a new tab. We got no warning now, so you can see the connection is secure and the certificate is valid, and it was issued by Letsencrypt for this FQDN. This is really amazing and super simple. By the way, as you might have noticed, this certificate generation process is not very transparent. Sometimes it happens that there is a config error or the certificate cannot be generated and for whatever reason. And then you might wonder, how the hell do you know at which point it failed and what is the actual problem? And what will help you in these cases is the troubleshooting page of Cert-Manager. So this explains how to troubleshoot all the different steps that happen in the background, like querying the certificate request, query the order object, and so on. You get some log lines and you get some output from the ACME service of Cert-Manager. And quite frankly, this saved my butt a couple of times when I had problems with my certificates. So definitely read this guide, go through it if you encounter any problems with this process. Alright, so I think at this point I could just let you run and do your own experiments. However, I quickly want to show you something else that might be very useful, because some of the questions I had in the beginning were, do I always have to create these ingress or ingress route objects myself, even when I want to deploy applications using Helm, or how do I set the TLS certificates in all those settings and so on? Let's do a quick example and deploy another application on this cluster, like Portainer. Some of the long-term fans here on the channel might remember when I used this application quite heavily. Today, not so much, to be honest, but anyways, it doesn't really matter. It's good for a demonstration like this. Because many Helm charts have default settings for creating ingress objects and sometimes even adding TLS secrets to be automatically generated and managed by the application chart, which is pretty nice. So here, for example, you can see the Helm chart configuration options of Portainer. And if you scroll down here, you can see there is a setting for ingress enabled, which automatically creates an ingress object for Portainer, which is set to false by default, because it usually creates a service object using a load balancer, if you might want to expose Portainer directly. But of course, if you want to use it in combination with a Traefik ingress controller and a Cert-Manager for creating a trusted TLS certificates, this is so much easier to deploy it this way. So yeah, let's deploy Portainer to this cluster. First of all, I want to create a new namespace for this. So create namespace Portainer. That's fine. And now I want to, first of all, I want to create a TLS certificate for this. So I'm just going to call it Portainer certificate.yaml, and I want to copy everything that I have in here. So if you got your templates, this is quite nice. Switch it to Portainer, and yeah, we're using the same cluster issuer. We're using a different subdomain of the hostname, but that's fine. Yeah, let's just apply this. And while this is running in the background, I will start creating the Helm values file for this. So Just gonna call Portainer values, and then I'm gonna add a couple of those settings here from the documentation. First of all, we want to change the service type because the default is load balancer. That would get a new external IP address from the kubeweb load balancer. We don't need that because we're using Traefik. So we're gonna switch the service type to cluster IP. That's fine. What we need to do is, if we go to this documentation here in the host objects, we can set the URL for Portainer. So that's what we have to do. Let's create a new host object here. Just gonna call this Portainer kube test1. And then we want to define the paths. I think we just need the port and set it to 9000. And here in the TLS object, we will use the secret name. So that is quite nice. There you can define the Portainer secret that has been generated by the certificate of Cert-Manager. So we will use this secret name that contains the certificate chain that is valid for this DNS name. And that's it. Let's first check before we deploy this if the certificate is ready. This is true. So yeah, certificate is created, it's signed, it's valid and ready for us. So we can deploy and install Portainer. We don't need to create this namespace as it is already created, but we will deploy it using these Portainer values here. So that will automatically change the settings, generate the ingress object, and so on. So if we deploy it, it's starting the ports. So here you can see it created a new ingress object for Portainer on this DNS name. So that should be fine. Let's see if the application is now running. Let's try to open a new connection. And yeah, that's it. As you can see, we just deployed Portainer on this Kubernetes cluster with a valid and trusted TLS certificates and using Traefik as the reverse proxy. Alright, so that's how I'm managing access to my applications in Kubernetes. I think this setup is really nice and it saves me a lot of work when I'm deploying applications like we did in this Portainer example. With Traefik and Cert-Manager, I can easily secure and encrypt the access to all of my applications. And yeah, I hope this video helped you a bit. By the way, I'm planning to do more videos on topics like this, for example, Kubernetes metrics or secure authentication and many more ideas I have in mind. So if you don't want to miss that, please make sure to check out my Patreon page. If you feel all these free tutorials I'm creating are valuable to you, then please consider supporting me there to ensure I'm doing more of this. And thank you so much for watching, everybody. Enjoy the rest of your day, and I'm gonna catch you in the next video. Take care. Bye bye.